Hi, this is Jim Wright, and in this video we'll take a look at using solid edge 2D nesting with odd shaped sheets. I received a question the other day, can 2D nesting be performed with odd shaped sheets? And there are a couple of areas where this might be important. For example, if you're using leather goods, obviously the exterior shape of the hide will be different with each animal. Also, live edge wood, if you want to nest into that, that could result in a problem where you need to know exactly what the outside shape looks like. And the answer is yes, we can do this, and I'm going to show you how in this demo. Let's get started. In Solid Edge, I've created a sheet metal document. I'll switch to the ordered mode and then create a sketch that I can create the irregular shape with. Tools, Insert Image. On this image that I took of the live edge wood, I placed a scale that I know the length of, so I can measure that to see if I'm close to size. Inspect, distance. This is only 1/3 the size that I actually need. So we can do one of two things. We can either adjust the size of the picture before we draw the object, or we can scale the body after we draw it. They're both about the same in terms of steps. I'll choose the latter method. Using my calculator, I calculated the new width of the object. Check the distance again. Very close. That should work. Now we can use curves to identify the outside edge of the live edge wood. I can repeat this as I go along the edge of where the live edge wood meets the bark. Because these are splines, I can easily edit them after I've created them. Once I'm done, I can close the sketch and create a tab. But first, let's assign the material properties. The last step is to make a flat pattern. And then save the file. Using the same procedure that we just demonstrated, I created a beef hide. So let's import that sheet so that we can do some nesting with it. Notice the hole in the beef hide. That was an area that the manufacturing team said they did not want to nest anything into because it represented a bad area of the hide itself. We can submit this hide. Now, if necessary, we can rotate the hide to an orientation that better suits us. Then we simply say, I want to use that as my sheet. Next, we'll bring in some seat components in a DXF DWG format. These particular files came from our NX brethren with the FiberSim master trim application. And you'll notice that even though it was a single DXF file, it brings in all the particular components as separate 2D shapes. You'll notice that there's a little line on most of these. We need to make sure that that line orients properly with the grain direction. We can use our rotate mirror functionality to change that. Because the color of the grain varies from hide to hide, it's important that we go full set of each seat from one hide. This is a fairly large hide, so we'll try for 4 seat sets. Under nesting, it's important that we specify rotation as 0 and tilt as 0 also. Part spacing is 3 millimeters between the data and 5 millimeters to the edge of the hide. Let's start the nesting process. It looks like solid edge 2D nesting can indeed get 4 seat sets out of a single large beef hide. Thanks for watching. My name is Jim Wright, and here is my contact information.